Hey everyone, welcome back. Today we're going to look at another way to solve a system of linear equations. So today we're looking at solving systems of linear equations with substitution. What substitution means is that we're going to substitute one equation into the other equation. Well, to do that, we're going to follow a few steps. Step 1 is to solve one equation for one variable. Then, in step 2, we substitute the expression we found in step 1 into the other equation and solve. And in step 3, we use the solution from step 2 to find the value of the remaining variable. Step 4, you write your solution as an ordered pair, remember, an XY combination. And then in step 5, you want to check that that solution works for both of the original equations. Always use the original equations. So let's look at the first example. Here we have the two equations, x plus 3y equals 3 and x equals y plus 3. Notice that that second equation is already solved for x. It's an x equals. So we know that x is y plus 3, so we can substitute this into the first equation for x. So our first equation is x plus 3y equals 3. And we substitute our second equation, x equals y plus 3, in for x. So we have y plus 3 in place of the x, plus 3y equals 3. Removing those parentheses, we have y plus 3 plus 3y equals 3. Now we combine the like terms on the left, and we get 4y plus 3 equals 3. Now we're trying to solve for y, so let's subtract 3 from both sides. That brings us to 4y equals 0. Now divide by 4 to isolate the y, and y equals 0. Let's start putting our ordered pair solution here at the top. So we know that y is 0. Since we know y is 0, we're going to substitute this in to one of the original equations and solve for x. Well, it makes the most sense to substitute it into that second equation because the second equation is x equals y plus 3. Well, we know that y is 0, so we substitute that in for y, and we get x equals 0 plus 3, or x equals 3. So there we have our solution to this system of equations, and that solution is x is 3 and y is 0. Now the next step is to actually check those solutions. So we substitute x in and y into our first equation and verify that it's true. Well, we have 3 plus 3 times 0 is 0 equals 3. 3 equals 3? That's true. It actually works for the first one. And then we check our second. Does 3 equal 0 plus 3? Sure does. 3 equals 3 is what that simplifies to. So we've checked our answer, and we know that this is in fact the ordered pair that solves that system of equations. And remember, what this means is that this is the point where those two lines would intersect each other. Now let's look at example 2. So here we have two equations, and we want to substitute one of them into the other equation. But one of the equations isn't already solved for a variable, so we need to pick which equation we want to solve and for which variable. I like to pick the equation that is the easiest to isolate a variable. And here that would be the second equation. Notice that y doesn't have a coefficient in front of it. So we can isolate just y. So first step, we're going to subtract 3x from both sides. And then that'll bring us to negative y equals negative 3x plus 1. Now to get just a positive y, we have to divide all of those terms by negative 1. And that'll give us the equation y equals 3x minus 1. Now that we've completed step 1 and solved that second equation for the variable y, we can substitute this new equation into that first equation for y. So we would have 2x minus 3 times y, which now is 3x minus 1, equals negative 4. We're going to distribute that negative 3. So 2x, negative 3 times 3x is minus 9x. Negative 3 times a negative 1 is a plus 3, equals negative 4. Combine the like terms on the left to get negative 7x plus 3 equals negative 4. Now we need to isolate the x, so subtract 3 from both sides. So negative 7x equals negative 7. Divide by negative 7 to isolate x, and we find out that x equals 1. So we'll start our ordered pair up here. We have 1, and we don't know what y is yet. So remember, to find y, we're going to substitute our x value into one of those original equations. So let's just use that second one. So 3 times 1 minus y equals 1, or 3 minus y equals 1. Well, subtract 3 from both sides so we can isolate y. We're left with negative y on the left-hand side equals 1 minus 3, or negative 2. We have a negative y, so divide by negative 1, and we find out that y equals 2. So our solution here is the point 1, 2. Now, we need to check this solution. So you're going to substitute 1 in for x and 2 for y into each of these equations and verify that it gives you a true statement. I did this, and these do verify, and this point 1, 2 is indeed the solution. So to save us some time, so we can look at a couple more examples, just trust me that it checks out, and 1, 2 is the correct answer. Let's look at example 3 and example 4. So example 3, we have two equations, and neither one of them is solved for a variable, so we need to identify which one is going to be the easiest to solve and for which variable. I would pick this first equation, and notice that if we add y to both sides, we've solved this for the variable x. So x minus y equals 4. If we add y to both sides, we find that x equals y plus 4. So we've solved one equation, the first equation, for the variable x. Now we can substitute that into the second equation in terms of our x. So 2 times our x, which is now y plus 4, minus 2y equals 8. Distribute that 2. We have 2y plus 8 minus 2y equals 8. Now we need to combine like terms on the left-hand side, and notice what happens. We have 2y and a minus 2y. Well, those simplify out to just 0. So we have 0 plus 8 equals 8, or 8 equals 8. This is what is known as an identity. So an easy way to remember that this is an identity is that both sides are identical. 8 is identical to 8. An identity means graphically you have identical lines. And remember, when you have identical lines, how many solutions do we have? Yeah, we have infinite solutions. So here, because we have an identity for our answer, we have infinite solutions. So example 4. In example 4, we have two equations, and it's probably easiest if we solve that first equation again in terms of x. So if we have x minus 2y equals 5, to isolate x, we need to add 2y to both sides. So that would solve to x equals 2y plus 5. So now we can substitute this expression for x into our second equation, which would give us 2 times that 2y plus 5 minus 4y equals -2. Distribute the 2, so we have 4y plus 10 minus 4y equals -2. Combine the like terms on the left and notice that we're left with 10 equals -2. Well, it's not possible for 10 to equal -2, right? No. So this is the case of no solution. And remember what it means when you have no solution. No solution means that those two lines are parallel. So if you were to rewrite each of those two given equations into slope-intercept form, you would see that they both have the same slope, which is why they're parallel lines and have no solution. Because they're parallel, they'll never cross. Let's go to the second page and look at a couple more examples. Yep, everyone's favorite, application examples, word problems. So remember, we're going to read through the word problem first to get an idea of what's happening and what the question wants us to do. So question 1 tells us a boat goes 120 miles upstream in 15 hours. The return trip downstream takes 10 hours. Find the speed of the boat without a current and the speed of the current. Okay, a few things going on. So we know that we have a boat and the boat travels 120 miles in different times. So that tells us we have a distance rate time problem where we need the equation distance equals rate times time. Well, it wants us to find the speed of the boat and the speed of the current. That's also called the rate. So we can rewrite this distance rate time as the rate equals distance divided by time, right? Or here it's going to be miles per hour. So notice we have a boat that goes upstream, and then we have a boat that goes downstream. So a boat that goes upstream means the boat is going one direction, and the stream is going the opposite direction. And then a boat that goes downstream, the boat and the stream go the same direction. Pictures are always helpful for these word problems. So what else do we know about this boat going upstream? Well, we know that upstream it can go 120 miles per 15 hours. Or it's traveling 8 miles per hour. And the boat that goes downstream, well, it's going the same distance, 120 miles, but it only takes 10 hours. So that's a speed of 12 miles per hour. Now we need a system of equations. So a boat that goes upstream goes the speed of the boat minus the speed of the stream, because the stream is slowing that boat down. So we get the equation b minus x equals 8. And then a boat that goes downstream, well, the boat and the stream are going the same direction, so it goes faster. So boat plus stream equals 12. Now that we have our two equations, we can solve one of them for a variable and substitute it into the other one. So I'm going to solve this first equation. If I add s to both sides, I get that the boat equals the stream plus 8. And now I can substitute that into my second equation. So I would have the stream plus 8 plus the stream equals 12. Combine the like terms, and I get 2s plus 8 equals 12. Now subtract 8 from both sides so that we can continue to isolate the variable s, and we have 2s equals 4. Divide by 2, and we find that s equals 2, or the stream is going 2 miles per hour. Well, if we know the stream is going 2 miles per hour, we can substitute that back in to our equation b minus s equals 8. So b minus 2 equals 8. Add 2 to both sides, and we know that our boat, B, is going 10 miles per hour. So our stream is traveling at 2 miles per hour. That's the speed of the current. And the boat is traveling at 10 miles per hour. Let's look at another word problem. Here we have a chemist, and the chemist has a 20% and a 50% solution of acid available. How many liters of each solution should be mixed to obtain 10 liters of a 40% acid solution? So in this example, I like pictures, and we have 2 containers that we're mixing together and creating a third container. And then we can fill in what we know about each of the containers. So we know that the chemist has a 20% solution and a 50% solution that he's mixing together. So those are the 2 on the left-hand side. And when he mixes those together, he gets 10 liters of a 40% solution. So we need to find how much of the 20% and how much of the 50%. So those are our variables x and y. And from this drawing, we get our 2 equations. So we will get the equation that x plus y equals 10 liters, because I guess we should identify that x is the amount of 20% and y is the amount of 50%. So x plus y has to be 10 liters. And then we know when we mix that we have 20% of x, so that means multiply, plus 50% of y, get mixed together, and that gives us 10 liters of 40%. Or that equation simplifies to 20x plus 50y equals 400. Now we can solve that first equation in terms of x. So we subtract y from both sides and we would get x equals 10 minus y. And we can substitute it in for the x in our second equation, which would give us 20 times 10 minus y plus 50y equals 400. Distribute that 20 to get 200 minus 20y plus 50y equals 400. Now we combine the like terms on the left-hand side, and we have 200 plus 30y equals 400. Subtract 200 from both sides because we need to isolate our variable y. And that brings us to 30y equals 200. Divide by 30. And we know that y equals 200 divided by 30, or 20 divided by 3, And that simplifies to 6 2/3 of a liter. Well, we know X plus Y has to be 10 liters. So X plus 6 2/3 have to be 10. So we subtract the 6 2/3 from both sides. And we find out that X is 3 1/3 liters. So what's our final solution then? We know X and Y, but we need to explain that or interpret it in terms of what the variables X and Y stand for. Well, X is the amount of 20%, so we can say we need 3 1/3 liters of 20% acid, and we need 6 2/3 liters of the 50% acid. And when we mix those two together, we end up with 10 liters of 40% acid. Have a question or a problem you want help with? Leave it in the comments and I'll include it in one of my videos. If this video was helpful, subscribe to my channel for more math tutorials. Thanks for watching. See you next time.